of these needs some work. I don't know why I don't fix it. I guess I'm entertained by it. This is using the theorem. Lesson 2. It makes no comment about whether I'm going to be doing part 1 of the theorem or part 2 of the theorem. It just says talk about the theorem again. Yeah? Using integrals to find areas. We start off with what should be an easy one, even if you're not caught up with the homework. So I'm going to teach this like you're a little confused about exactly how to use the fundamental theorem of calculus, part 2. Yes? Consider the integral -1 to 6 of x squared minus 9 dx. Evaluate the integral. Here's what we're supposed to have learned up till now. With some of the details mysterious, I give you full permission to be like, I'm not exactly clear on the intricate details of why this works. I have some of it. I got the gist of it. But boy, that got a little foggy there at the end. The good news is, at the end of all that development came the antiderivative. And to find integrals, we first find an antiderivative. This can be really hard. Really hard. It doesn't take much to throw you right off here to find antiderivatives. This one's not so bad, though. Well, let's walk through it again. X squared, I've got to, if I'm finding the antiderivative, increase the power by 1. And so what happens is that x squared becomes x cubed. And with derivatives, then we multiplied by the exponent. So here we divide by the exponent. I explained that last week, but it could be that that was a little much with everything that was going on. So that's why that 1/3's up front. If that bothers you, imagine taking this derivative. Derivative of x cubed is 3x squared. To have a coefficient of 1, it's going to need a 1/3 to cancel out with. Hopefully that's becoming a little more easy. I don't think I'd do that trick for constants. I think those are easy. I don't think about exponents or anything like that. I just go, the antiderivative of -9 is -9x. Fundamental theorem of calculus part 2 says, yes, find the antiderivative, but then evaluate it at the endpoints and subtract those two values. Not so bad. I use square brackets to manage this. I go, okay, this is the one where I'm going to sub in 6, and this is the one where I'm going to sub in -1. And I'm writing that just a little bit in a different order than I did last week to help you manage it. So I sub 6 into this thing, 1/3 times 6 cubed minus 9 times 6. Need that minus sign a little bigger there. And then this one's 1/3 -1 cubed minus 9 times -1. But let's just sit back and savor that for a second. Because that, hopefully, for most of you is like, well, I'll be okay now. Oh, that's not going to be too much. I'm more flabbergasted by this than I am the derivative, even after all these years. All that crazy rectangle stuff. Delta x equals b minus a over n, setting up all the rectangles, and it comes down to this. Like, it's not quite as simple as the derivative. But wow, like, maybe we did the derivative so much that it's like, oh, I know exactly what that means. Slope of a tangent. Seems simple now. All that area stuff, there's a lot going on. And that's simple? Can it really be that simple? Yes, it is that simple. Well, you can hammer these into your calculator, but I'm going to try. Because I know I've got a weapon. You have a weapon that makes it so I can worry a little less about this stuff. -1/3 plus 9. Don't get lazy now. Think it through. Plus 9, 54. 216 divided by this, yeah. 18 minus -8 2/3 equals 26 2/3. Are you clear why I'm so arrogant today about this? I know I got my calculator. Just jam this in there and make sure that I got it. You know, you've got an integral calculator. Moving into next year, could this be on an integral midterm with no calculator? I don't know. You're going to have to, that's day one. Find out in your calculus class how nuts they're going to be about calculators. Know what you're allowed and get the one that they suggest so you have it. However,
You sure that's correct?
no, I'm not. I did it fast on purpose. Yeah? And then I'm trying to show what you guys would do. Like you type it in, and then at least check this out. Integral x squared minus 9. Actually, I'm sort of hoping it is incorrect so that I can talk about what you would do in different situations. 9.33. Yeah, something definitely wrong there. Okay, now let's just talk about how we would manage this. If this was in your homework, you would beat this to death. You'd find out what the heck is going on here. If this was on a midterm, you'd stop there and continue on in the midterm and go, wow, I don't know what I did wrong, but this is the right steps. Yes? And not kill 20 minutes in your midterm trying to find some crazy error. It's hard to do. It's painful to do. 9 1/3. Let's see. Let's find out what happened here. This is positive 8 2/3. And so it's 18 minus 8 2/3, which is 9 2/3. I got lucky there. I saw it immediately. So maybe you're allowed to take one look. Take one quick look to see if you did something silly wrong, like a negative. And again, it's a negative. It's always a negative, right? Any questions about that procedure? I'm hoping that's starting to become okay. The antiderivatives can be difficult, but at least I know what I'm trying to accomplish. Antiderivative, evaluate at the upper, evaluate at the lower, subtract. And keep track of your negatives. Yes? No, I guess I wasn't sure it was right.
Isn't it
9 1/3. Thank you. Nine 1/3. Yes. Other questions there? All right. B, does the answer from part A represent the total area between the graph of y equals x squared minus 9 and the x-axis? Maybe. Maybe. But I'm going to use the answer I heard someone say out loud is, technically, it's the net area. And if that phrase bothers you or it hasn't been explained well enough for you, good, that's what I'm going to do right now. We're really going to get to the bottom of this, what we mean by net area. To do that, we need a graph of this thing. We need to know what the heck is going on. I don't know if we need a perfect graph. We just need to know when it has its zeros. So graph y equals x squared minus 9. Now, in this case, this is a parabola. Move down 9. I really want to know the zeros. So I'm going to find the zeros. And I'm going to do a little sketch of it and really get to the bottom of this situation. Find the zeros. 0 equals x squared minus 9. 0 equals x plus 3, x minus 3. I hope this is pretty straightforward for you. Therefore, x equals negative 3 and positive 3. Are we okay there? Find the zeros of a quadratic on a Monday? So then I can get a pretty good little graph of it. To really help out here. Negative 3, positive 3, and down here, negative 9. And then maybe switch colors here so you can really see the parabola. So what's going on here? They wanted the area between, sorry, the integral between negative 1 and 6. So now I need that on my scale as well. Negative 1, and I'll put 6 right there. Sort of compressed it in. You know, if you're doing this on graph paper, maybe you'll do a lot better than me, but this will be good enough. So what I found is, I found the integral between -1 and 6. So it's all this stuff. And I'm going to put in quotes, that's negative area. And I put it in quotes because it's like, well, there's no such thing as negative area. This is area that will be calculated as a negative. And over here, get another shading color here. Up here, that's positive area. Aren't all areas positive? Yeah, I know. This is area that will be calculated as a positive. So, the integral from -1 to 6 of x squared minus 9 dx represents, here's the whole sentence, the positive area between 3 and 6 subtract the area between -1 and 3. There's a better explanation finally of what we mean by net area. Net area is all the positives count as positive. Put that together with all the negatives. Now, is it subtract? I don't know. You could argue this is actually adding the two areas, and this one happens to calculate as negative. But that's a difference that makes no difference, as far as I'm concerned. Yeah? Does that help on the old net area thing? In applications, this is what we want anyways. If this was, going back to where we started with this, if this was a velocity curve, and we wanted to calculate displacement, we'd want the negative displacement and the positive displacement. We want to know how much did your displacement change, so we want positives and negatives all the time. More physics. If this was a force graph, and this was displacement, and we wanted to add up all the force times displacements to calculate how much has the energy of the system changed, we'd want the negative energy and the positive energy. We want those things to be added together. We want the net. What's the result here? Math people jump in and go, well, that's fine for physics, but I want this to be the area. What am I supposed to do here? Anyone look at the picture and tell me exactly now what to do to get the area? How much area is between the curve and the axes? Like, how much is this plus this? What am I going to do?
Just add the magnitudes.
Add the magnitudes. Remember, he said that. Okay? The magnitudes from where to where and from where to where? Because that's the important part.
-1 to 3 and 3 to 6.
Okay, so that's what we're going to do next. Is go, if we want the area, math people are like, I don't care about your little energy problems. I don't care about your little displacement problems. I want area. And next chapter, we're going to want volume. But don't let that scare you right now. I don't want negative volume, positive volume. I want the actual area here. So to do that, it says determine the total area of x squared between x squared minus 9 and the x-axis. Then we take this integral from -1 to 6 of x squared minus 9 dx, and we say, no, I'm going to find the integral from -1 to 3 of x squared minus 9 dx. And I'm going to add to that the integral from 3 till 6 of x squared minus 9 dx. And there's a mistake here. Well, not a mistake. There's something missing, but in the interest of really understanding what's happening, I'm going to proceed as if I haven't forgotten to do something, which Cole already mentioned. But I'm going to pretend I didn't hear it. And that's right in your picture. By finding the zeros, I know what to do. Go from -1 to 3, and then go from 3 to 6. And in the interest of practicing it, if you're a little behind on doing these integrals, we'll do a whole practice of doing the integrals again, and then we'll talk about what the answer means. So I'm going to move way over here just to make sure I have enough room. Antiderivative, well, I already know what that is. 1/3 x cubed minus 9x. And I'm doing that from -1 to 3. And I'm going to add that to this area here, which is 1/3 x cubed minus 9x from 3 to 6. Some things have about to go wrong, and then we'll need Cole's idea. He already saw through what's going to happen here. So this first one here, and I'm going to use curly brackets just because it's fun to put curly brackets into this thing. Here's the first area. Let's see. 1/3 3 cubed minus 9 times 3 minus 1/3 -1 cubed minus 9 times -1. That's the first one. Subbed in 3, subbed in -1. Did it. Plus this one, and I'm using curly brackets again. You can use curly brackets if you want, or you can use something else, whatever you like to stay organized. And then over here, 1/3 6 cubed minus 9 times 6 minus 1/3 3 cubed minus 9 times 3. Let's see how I do here with the mental math this time. This one's 27, 9 minus 27. And this one's -1/3 plus 9. Oh, that's the exact same error I made a minute ago. Okay, so get that right this time. And this one's 72 minus 54. That looks familiar. And this one's 9 minus 27. Ooh, I better check that. I feel like I fell asleep there at the end there. 6 cubed is 216 divided by 372, 54, 27, 9 minus 27. I like it. So this one's -18 minus 8 2/3. Don't give me a hitch there as I worry about the negatives. But I got it right this time, I think. Yeah? Plus this brackets 18 minus -18. So this is -26 2/3 plus 36. Now I just need you to stare at that for a second. Catch up with your copying. And then we'll be ready for what Cole said before. This is about to give the answer 9 1/3. This has accomplished nothing so far, except to make the calculation a lot more steps. That actually makes me feel good. I'm like, I'm going to get the answer, 9 1/3. But if I'm actually going to find the total area, what has to change about the situation? Yeah, this has to be positive, okay? I can remember doing these when I didn't even worry about it. I'm like, one's going to be negative, one's going to be positive, or they're both going to be negative. I don't care. I'll fix it later. But technically speaking, what I should have done is what Cole said at the start, is put an absolute value around this the whole time to say, no, I want the positive areas. I'm adding up area. So that absolute value would be on every single line. I'm adding all the absolute values here to all this stuff. And now that's positive, and I get answer 62 2/3. That's the actual total area. Check it out in your calculator, though. Let's see if I can get some calculator magic going here. I think there's a problem with mine, but I'm not sure. I'll try it. So, integral on your calculator, you can put the absolute value right in the brackets and get the right answer. So I got to find an absolute value thing. Oh, there it is. Absolute value. Oh, it gives me absolute value bars. I can put that right in there. X squared minus 9 from -1 to 6. Could I break it up and check each step of the calculation along the way? Absolutely. But if I'm just using my calculator to go, did I get the right answer? I can put the absolute value bars inside 62.666, which really is really interesting that it doesn't know it's 62 2/3. It's using a Riemann sum. It's not doing antiderivatives. It's adding up a whole bunch of rectangles and going, it's about right here. And I'm like, wait a minute, I'm smarter than the calculator is now. Really? Fascinating. Any questions on that? I'm hoping that ties a big bow on that whole idea now. It's like, okay, negative areas, positive areas, net area, zeros. You can see the whole picture now. Questions there? More time? We're good? So I put that right in the notes. How to find total area analytically. Partition the interval with the zeros, integrate over each subinterval, and add the absolute values of those pieces together so you can get the total area. Is this good? I feel like that really should have been part of other lessons, but there wasn't enough time to go, let's just do this for a second because it's not that hard. It's long, but it's not that hard theoretically. Okay, so a couple calculator questions. Use your calculator to find net area of this graph between -3 to 3. And I've given a version of the graph here, but I want you to see this one more time, this interesting result, so you're not surprised by it when it happens and you understand what it means. This says integral, let's just check if I'm in radian mode. Yes, I am. Integral, not that it actually matters this time, but x cos 2x, which is an integral You want something to do tonight? Just play around and see if you can figure out what the antiderivative of that thing is. It's a real problem. It's a for real problem. It might not even be possible. I don't know in my head. From -3 to 3, let's just put this in here. We're finding net area, so I don't care about the positives and negatives. I want the net result, physics people. I want the net result. I want to know what this function accomplishes between -3 to 3, and it accomplishes nothing. But if you look at the picture, can you see why? Any symmetrical situation might do this. And specifically, this function's even. And even functions always do this. When you've got an even function, it's the same on both sides. Sorry, odd. Whoops. That's odd. Yeah. Any odd function will do this over a symmetric interval around the origin. Okay. So then it says use your calculator to find the total area. The graph on the right might be helpful. Here's the absolute value of this thing. So this is the graph of absolute value of x cos 2x. So when I put those absolute value bars inside, all I'm saying is let's just make the whole function positive before I even start. Then the calculator can do it without breaking it up with zeros, and so then I can go do the exact same thing. If you look through the menus, you've got an absolute value button, and then it's x cos 2x from -3 to 3. Answer. Look at this. Did you see how mine was pretty quick? My calculator's hooked up to the brain of that computer. So it was fast. But on yours, you see it go and think. Begging the question, what the heck is it doing? Right? People that want to go into computer programming, This just touches your, just lights up your hippocampus. Where's the biology people? Is it the hippocampus that you, like when you're really into something, your brain just lights up and you're like, whoa, I gotta know, what's that thing doing? Last year, someone did their project on programming the inside of this calculator and making a program on using Java that does some of this stuff. It was very fascinating. He got it to do areas. He got it to program. It was pretty good. Let me read all these decimal places just so you got it exactly right when you typed it in. Careful now, don't turn that off. 425, 2414. Approximately, it must be approximately. I feel like it must be. With the way that thing thought it over, it wasn't doing it analytically. It wasn't actually getting the answer. It was going, I don't know, something like this, I guess, I don't know. I mean, it's doing it to 9 decimal places, that's fine, but boy, that took a while. Have you ever seen that thing hitch like that before? It's insane. Computer programmers, it must be something like this. It must do 10 rectangles, and then do 20 and see if the answers are close. And if they're not close, it goes again. And if those aren't close, it goes again. It must have some self-checking mechanism in there to go, is this a good answer? And if it's not, it goes again. And it must have been like, it's not settling into an answer. And it kept going until it did settle into an answer. I think. I don't know. I think. My programming experience tells me that. Questions there? I don't think you'll find those particularly difficult now that you have to type them in the calculator. What's that? Is that the last one or is there more? Oh, mama. When this is all over and you're there on grad night, sitting there, trying to stay awake through your grad, and you're sitting there comparing and going, what are the toughest questions I saw in all of high school? This one will be in the Hall of Fame. Maybe. Maybe. Maybe I'm just that good and I'm going to explain it and you're going to be like, oh, I don't know what he's talking about. Seems pretty good. This is really hard. A, B, C, D, E, and they get progressively harder as they go. Whew. All right. Let's be careful now. Let's read this carefully and we understand what's going on. Because understanding what integrals mean is way harder than understanding what derivatives mean, what the actual meaning of this all is. The graph of a continuous function f with domain 0 to 8. This function only goes from 0 to 8 and then stops. That's an important detail somewhere on the way, I forget where. It's shown on the left. Let h be the function defined by h at x equals integral 1 to x of f at dt. What the heck does that mean? Let's imagine that we could actually do these integrals. We were that good that by either coloring it in or by building little rectangles, or we've got an integral meter, little flashlight, then we shine it on a certain area, boom, the area shows up, okay? Let's just pretend we can do that. This function, what it's doing is saying, well, what's the integral from here to here? So for instance, there'd be different x values over here. Here's the idea. Here's your thought bubble of what the heck is going on here. This is really important to even understand what the heck is going on. Otherwise, you got to leave this question blank because you don't even know what it's asking. Here's what it's asking to do. It says, I'll give you an x value. Maybe that would be a homework question. I'd say, Cynthia, you go do this x value. Agam, you do this x value. Ben, you do this x value. And everybody's got an x value to go home and find out what the integral from 1 to x is of this function. Find the area for each of these. I think I can already see some good x values to choose. Let's do one. I think there's a really easy one that I can sub in the x value and get the answer really easily. Like not just sort of the answer, not a guess at what the answer is. I'll know exactly what the answer is. What x value can I easily get the answer for? Kevin, 1. That's the first level of breakthrough on questions like this. That came up in a previous lesson. Well, I don't know everything, but I do know if I put in x equals 1, this will be the integral of 1 to 1 f at t dt equals 0. Okay, so that's the game here. The game is to find h at x. That's this column here. To find h at x, find integral from 1 to whatever it says. That gives us a chance to even talk about what this question wants. The first one says find h at 1. Oh, that's the one I just did. Yeah? Well, let me write it out. Because when you run into questions like this, it says h at 1. You look at the picture, like, I don't even know what that means. So you go back to the function and you do what you always did with functions. Sub in the 1 to see what you got there. And it's integral 1 to 1 f at t dt equals 0. Now, if you're right with me, if you're not, it's okay. You don't have to, you can ignore this. I think there's a mistake in the picture. I think this should be a t. The x isn't the x-axis. It says in the question it's a t. But I think they didn't worry about that, and I think they actually, when they made up this question, they might have known that. But if they put a t there, everybody might get a little upset. Right? But the x is just whatever x value I'm going to use along here. Next, h at 0. Is h at 0 positive or negative? What a horrifying question. Because if I said, find this area right here, and I pointed out with my finger, you'd go, that's a positive area. It's above the x-axis. It's got to be positive. You're like, hold on. I agree. It probably is. But let's just sub in. Yeah? That's my first big lesson on questions like this. If they want h at 0, let's just sub in 0. Humor me and sub in the 0 and see what you get. So if I go h at 0, I'll get integral 1 to 0 f at t dt. Now give that a long stare to see I mean, there's nothing up my, I don't even have sleeves today. There's nothing up my sleeve. I'm not doing any magic. All I did was take the 0 and put it in where they said to put it in for this function. This says find the integral from 1 to 0, which somebody snickered. Why would you even do that? I don't know, but that's what it says to do. So I've got to find the integral from 1 to 0. Now that's a problem. Visualizing integral 1 to 0 is no mean feat. I would much have preferred if it was integral 0 to 1 of f at t dt, which I'm totally allowed to do, but who's with me? What do I got to do? Negative. And I'll explain that if you're like, again, if you're like, why would it be negative? How could it possibly be negative? I'll explain it in just a second why it's negative. And yes, integral from 0 to 1 of f at t dt, I can see in the picture, that's a positive area. So this answer comes out to be negative. And then it says explain, which I don't have much room to do. So I'll switch colors so you can see me explain. It has positive y values. That could have been your objection when I started to play around with this. It's got to be positive. It's all positive y values. I'll get positive y's the whole way, but negative intervals in this calculation. So if I'm going to go 1 to 0, every one of those intervals goes backwards, and instead of being 0.9 to 1, it's 1 to 0.9, and when you subtract those to get the width of the interval, you'll get little negatives. Oh, you can be angry if you want. You can be looking at that going, are you kidding me? Who would set up something like this? And I'll say a line that I really believe. I really, truly believe this, and maybe this will help you in your future math and science endeavors. Math, science, biochemistry, none of these things are complicated. The world is really, really complicated. Math and biochem are just describing what's going on. So in the middle of doing some crazy calculation, trying to figure something out, you'll get something like this. And you got to deal with it. The facts are this will be calculated as negative. It's not a setup. It's not a calculus trap. It's the kind of thing you might run into when you're doing calculations on complicated endeavors. Whew. Nice speech, Coach. That's tough. Let's see, on a scale of 1 to 100. 100 being the toughest questions we see in high school. That's a 99. Don't underestimate that. That is difficult to see that. And if that's a 99, this is 140. Find the value of x for which x for h at x is a maximum. No, I've got a great way to explain this. I can make this easy. Let's say we go home tonight. A gum gets given x value 0. Cynthia's got x value 1. Nick's got x value 2. And you all go back and find the areas. Remember, you've got a magical area flashlight, a magical integral flashlight that you just shine in here. You just use your photomath zoom thing, and you zoom in on the thing, and it goes boop! Yeah? And if I zoomed in on this right here, that would be calculated as a negative. Yes? That's negative. I know it looks positive, but in the calculations, we just decided that'll be a negative. After 1, life gets easier. This part here, that'll be calculated as a positive. Yes? What about this part here? That's now a negative area again. It's not a negative area. It'll be calculated as a negative value. When is h a positive, a maximum? It goes negative stuff, so that's negative values. Then I start adding values up to here. Then I start subtracting values from there. When do I get the most possible area? The most possible area in the calculation. There's an x value there where I've now got as high as I'm going to get in my area calculation. That is, if I took it up and the gum did 1, then 2, then 3, then 4, then 5, and each of you quoted your area, who would have the x value that gives the most area? Kevin's holding up some fingers, so he gets to answer. I'm going to do some quality teaching here. Kevin, are you up to back-to-back answers? 1, you've got to give your answer. 4. 4 is correct. But now he's got to explain. For our purposes, he's got to explain. Did I explain it too much? You explained it too much. Oh, yeah. Can you tell us why? Oh, yeah, yeah. Up until that moment, see, there's more positive than negative. I can see that in the picture. I think they've cleverly built the picture so no one would disagree that this would now be positive area. Yes, there's some negatives, then some positives. We've now got a pretty big area. Then after that, we just start subtracting area. Whoever had x equals 4, Bennett had x equals 4. He quotes his answer, 7. After that, everybody after that is going to give a lower answer. That's as much area as you're going to see. Okay. If that's challenging, this is dangerous, but give each part a little value and say what would happen. Let's say that's a -1 and that's a +3. After there, you've got area 2, and then you just start taking area away after that. Knowing all that, find the value of x. Apparently, there's only one value of x, where this thing is a minimum. Who will get the lowest area in all this? What x value will you get the lowest possible number? Who wants a shot? What's that? 8 is a very good answer. 8 is a very good answer. It's incorrect, but it's a great answer. At 8, we've gone low, low, like negative, 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 negative. We've gone down, 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 and then but we really need to know what happens next. For it truly to be a minimum, we need to know, then does it go up from there? Right? For instance, my bank account did this last week. I was trying to give my 2 wonderful university children who are monetarily challenged, I was trying to explain to them something that happens to my bank account. Negative, 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 negative. They trust me at the bank, actually. They'll let me go negative as long as it, at some point it starts coming back. Negative, 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 till payday. Now, that's only a minimum if I get paid the next day. Maybe. We could argue about that. I'm willing to argue about that and say, I'm going to put it over here. I'm going to put 8, question mark. Most textbooks won't consider that a minimum. But I like the answer. What x value, though, do we know for sure it's a minimum? Caroline, 1. Let's do my bank account again. Losing money, losing money, losing money, losing money, losing money. This is my whole life. Gaining money, gaining money, gaining money. This is a positive negative chart. That's what this thing is. I'm hoping that's the difference this year, because I can explain it in such a way that people go, oh, if I just build a positive negative chart, I know what H is doing. Downwards, upwards, downwards. When it goes from negative to positive areas, minimum. When it goes from positive to negative areas, maximum. Maybe that's good. Maybe I'm finally good enough to explain that in a way that people go, oh, this isn't so bad. Just put little positive and negatives in the areas, how they'll be calculated, done. I'm downgrading that question, you say. Scale of 1 to 100, I call that an 87. I'm like, okay, watch this. Find the x-coordinates of all points of inflection for the graph y equals h to x. You might look at this and go, there. I can see where the points of inflections are. No, you can't. This isn't a graph of h. This is a graph of f. What I'd like to do, here's what I want to do, and I think you should do, is you go, well, y equals h at x. I want h prime, and then I want h double prime. That's what I really want to answer this question. I want to take the second derivative of h and analyze that. To which I answer, do it. You know what h at x is. Here it is. Y equals h to x. Y equals, what was h at x again? Where is it? Integral 1 to x, f at t dt. And your brain stops. Because you're like, well, it's an integral. How am I supposed to take its derivative? Fundamental theorem, calculus part, what's going on? Have you been listening? Were you in a coma? No, that's a bad example. Don't put x in there. Square root of 9 squared is 9. Exponential log. Sine inverse. Derivative of an integral is the function value at the right-hand endpoint. That's deep. That is deep. The derivative of h is f. To which you go, okay, that's fine. But now I just got an expression f prime. That's not very helpful. And here comes the best sentence of the day, by far. This is Hall of Fame stuff here. I'll switch to the color gold. Does it appear gold on your screen? Oh, that's going to look like the red, isn't it? Yeah, I'm going to do it anyways. H double prime at x will change sign when f prime changes sign. Because h double prime is f prime. That should be a mic drop right there. Yes? Call Pizza Hut and order 4 pizzas. Because you're like, let me ask this question instead. When does f prime change sign? There's the graph of f right there, friends. When does f prime change signs? That's when it goes from decreasing to increasing, or increasing to decreasing. Here, there, there, there. There's when the derivative of that function changes sign. At 1, it goes from negative derivative to positive derivative. Answers. X equals 1, 3, and 6. On a Monday, Mr. Todd? Really? I'd like to go back. I'd like to get my DeLorean and go back and not teach this till Tuesday when I was more prepared. Those are difficult. Hold on. A, B, C, D, E? A, B, C, D with a little bit of work. Those come back and go, okay, I think I can manage this now. E? Oh my. Trouble.